Hello everyone, my name is Sai Harsha and I am here to explain about curve fitting and my roll number is 50. What is curve fitting? Curve fitting is the process of constructing a curve or a mathematical function that has the best fit to a series of data points, possibly subject to constraints. Here we are drawing a curve or a function which fit the set of data points and we are giving some constraints to it. And thus a smooth function is constructed that approximately fits the data. In curve fitting, we have many number of fittings, and some of the fittings are linear and polynomial. And I am here to explain about linear and polynomial. Linear, as you can see, a straight line, and the equation is y is equal to a1x plus a naught, and it is a linear relation between y and x. And a naught represents the gradient. A1 represents the gradient of greater or slope of the line, and a naught represents the intercept. Here we have taken, let we have taken n reading for x and y of some line or some function. Then we should have an equation form in the form y is equal to a1x plus a naught, or we need to turn the equation into this form. Unfortunately, we have some errors. Uh, we represent the error with e, and which is equal to y minus a naught plus a1x, and we sum up the error and individually squares them, and we equate to one variable which is s, and then we differentiate s with respect to a naught and a1, which is partial differentiation, and we get two equations, namely n a naught plus a1 x is equal a1 x minus a y1 is equal to 0, and another equation is ax plus a1 x square, which is xy, and we equate those if we equate those two equations, which is n a naught when n a naught plus a1 x is equal to some y, and xy is equal to n a naught plus a1 x square, and we substitute the values, and if we substitute the values and we take the values of uh, a1 and a naught, we get an equation or line equation in this form, which which nearly passes through the data points. This is linear fit. Here we mainly need to know the equation, which is y is equal to a naught plus a1 x, and we may not get some fits correctly in linear, so we go for the polynomial, and the line equation is polynomial equation is y is equal to a naught plus a1 x, and so on to a1 a2 x square, and so on to an xn. We take polynomial for fits like this in order to best fit the data points. For example, we take paid labor hours and profit. If the labor works for the more hours, so he get more profit. Uh, in order to set these data points or fit these data points, we use different polynomial equations. And here is one example. We are given with the data points or the data. We take the summation of the xi and yi and xi square, xy square, xi square, and xi power 4, yi and xyi, and so on. And we are given with the output, and which is an equation or equation. And if we plot that equation in the graph, we will get a line equation which is nearly touching, or which is best suit for the data points given. It is passing through through these data points, and it is very useful if we want to further know the data points or further know the data points to fit, or in order to predict the next data set or data set point. So it is very useful, and we can use many polynomial equations, but uh, I suggest second order and third order. If we go on for the more number of polynomial series, it it outputs the data, and which may causes which may raise errors. So in order to least the number of error, we we often use two and third, second and third degree, uh, first degree polynomial equation. We rarely use both. Thank you.